All right, the last piece of the puzzle in terms of manipulation. Now, what happens if, all said and done, what we end up with in our denominator is actually one of those binomial versions of an irrational number, where we've got something like 2 plus 3 root 5 or 4 minus 2 root 3. We still need to rationalize the denominator. There's a radical in the denominator. Etiquette says we're going to remove it. Now, we need to think back. The last time we had to remove a radical from the denominator, it was the square root of -1. Now, in doing that, we had to think about what a conjugate was. The idea of a conjugate is that these irrational numbers, just like our imaginary numbers, come in pairs. So if I've got something of the format a plus b root c, its conjugate is a minus b root c. Now, when I multiply those things, just like with imaginary numbers, by the time I'm through, they'll no longer be a radical piece to the expression. So a plus b root c times a minus b root c. We can see all the pieces that are involved. All said and done, the two middle terms will cancel themselves out. They're direct reflections of each other. And if you look at that term on the end, minus b squared root c squared, that's a square root with a perfect square underneath. That radical will also go away because we'll be able to evaluate that term, eventually getting us a squared minus b squared c. The most important thing being there's no more radicals, which means if we carry out an operation like this on our quotient with our binomial denominator, we won't have radicals in the denominator anymore. Now, looking at what we've got, 3 root 2 over 5 plus 2 root 3. The conjugate of that denominator is going to be 5 minus 2 root 3. We multiply by 5 minus 2 root 3 over 5 minus 2 root 3. In the numerator, it ends up being monomial term times the binomial we distribute. In the denominator, it's conjugate times conjugate. It's still binomial times binomial. We use the distributive property. But if you look at the results, 25 minus 10 root 3 plus 10 root 3 minus 4 root 9. Those, again, just like our generic example on the right, the middle two terms are going to disappear. We're left with 15 root 2 minus 6 root 6 over 25 minus 12, 12 being 4 times the square root of 9. All said and done, 15 root 2 minus 6 root 6 over 13. No radicals in the denominator. We've successfully rationalized our denominator.